Important formulas in functions. The first one, if the number of elements in the set A is m and the number of elements in the set B is n, then total number of possible functions from A to B is equals to n power m. Next, second formula, if the number of elements in the set A is n and the number of elements in the set B is m, here m is greater than or equals to n, then total number of one-to-one functions from A to B is mpn. The formula for mpn is m factorial divided by m minus n factorial. Then the third formula, if the number of elements in the set A is m and the number of elements in the set B is n, then number of onto functions from A to B is, so we follow this formula like nc0 n power m minus nc1 n minus 1 whole power m plus nc2 n minus 2 whole power m minus nc3 n minus 3 whole power m plus and so on nc n minus 1 1 power m. Next, last formula, if the number of elements in the set A is equals to the number of elements in the set B is equals to m, then the number of bijective functions is m factorial. Now we will discuss some examples based on these formulas. See the first example. If the set A has the elements 3, 4, 5 and B has A, B elements, then total number of possible functions from A to B is, so first count how many number of elements in set A. So number of elements in set A is 1, 2, 3. 3 elements. Next, number of elements in set B is equals to 1, 2. 2 elements. Now we need to find total number of possible functions from A to B. So see the formula for this. See the formula. So the data matches with the first formula. N of A, N of B, total number of possible functions from A to B. The formula is n power m. So total number of possible functions from A to B is equals to, so the formula for this is n power m. N power m. You compare n of A is equals to m, means m is how much? Here m is 3. So this value is m and n of B is n. So n of B is, this value is n. Now the formula is n power m. So what is n here? 2. 2 power, what is m here? 3. So 2 power 3, answer is 8. So 8 possible functions from A to B. Next, see the example 2. Example 2 is the number of onto functions from set P is equals to A, B, C, D to set Q, U, V, W. First write n of P. N of P is equals to how many? 1, 2, 3, 4. So 4 elements. Next, n of Q. 1, 2, 3. 3 elements. Now on to functions formula. See that. What is the on to function formula? So it is on to function formula. That is nc0 n power m minus nc1. So like this we write the formula here. Here n is what? Here n is n of b and n of a is m. So we write here n of a m, n of b n. So right here what is n of a? M. N of b? N. So n of a, it's like n of a, the first one, a to b. They said here a to b means here p to q. It's like a to b. Means compare p is a, q is b. So n of a is m, n of b is n. So write the formula. What is the formula? nc0. What is n here? So write nc0, that formula. N is how much? 3. So write 3c0, 3 power n power m. M means 4 minus 3c1, 3 minus 1 power 4 plus 3c2 into 3 minus 2 power 4 and minus 3c3, 3 minus 3. So simplify this. 3c0 1, 3 power 4. We'll write this value 3 power 4. 81 minus 3c1. 3c1 is 3. How we find the 3c1 value? It's like 3's NCR formula. NCR is equals to n factorial by r factorial into n minus r factorial. So here n is 3, r is 1. So write these values in this. You get 3c1 is 3. Then 3 minus 1, 2 power 4. So this 2 power 4 value directly I will write 16. 16 plus 3c2 value. So 3c2 value is 3 according to NCR formula. Next 3 minus 1, 3 minus 2, that is 1. 3 into 1, 1. And it is 3 minus 3, 0. It is 0. Now simplify this. 81 minus 3 into 16 plus 3. That is equals to 36. So number of onto functions from P to Q is 36. Next question is the number of bijective functions from set A to itself when A contains 106 elements is. So now see the formula for bijective, number of bijective functions. See, number of bijective functions. N of A is equals to N of B is equals to M. Here they said set A, when A contain set A itself means here N of A is equals to M and it itself is M. So the formula is M factorial. So here how many it contains? The elements are 106. So answer is 106 factorial. It's like M factorial. M. We are using M factorial. So M is here 106. 106 factorial.